Hello. So for chapter 12, let me bring it up here. We're talking about correlation. And let's see if we can. There we go. When we're talking about two different types of data, we want to see if there's a relationship between them. And this shows you the different possibilities, because if we plotted the points, the x and y, on an axis, and it shows you how strong the relationship is. Notice this one's all on the line and it's increasing. The more you study, the better your grade, and so that would be a strong relationship. Here R is 0.8, and notice the data is close to the line, so that's showing a strong relationship. It's positive because it's increasing. Notice 0.3, the data is more spread out, but there's still that relationship. It's kind of increasing, but it's not very strong. It's weak, but still positive. Where this one, it's all over, there's no relationship at all. Notice the negative R's, they're similar. Negative 0.3 is the same as 0.3 here, except that it's decreasing. Negative 0.8 is still a strong relationship, except it's decreasing, just like your slope. And the last one, they are all on the line. So it's a very strong relationship. So between 1 and negative 1, the closer it's to 1 or negative 1, the stronger the relationship. The closer to 0, the weaker the relationship. And your sign on your R value, which is called the correlation, will match your slope of the line. And that's what most of this is telling you. So if we have R equal 0.8, there's a strong positive linear relationship. An example of a negative 0.2, so that would make it weak, but it would be a negative relationship. The slope would be decreasing. And then a student's absence in their grade, well, you always look at the x value increasing. So as your absence increases, your grade would decrease. So that would make it a negative relationship. Warmer air and air conditioning cost, well, as the temperature in the air increases, it's hotter, so we'll use more air conditioning, so air conditioning will increase, which means a positive relationship. If a chicken increases in age, the amount of eggs it produces. So as the chicken gets older, it would produce less eggs. So that would be a negative relationship. Correlation never implies it will cause it. So on the ones where they're saying it causes this, it's not cause it. It's just an estimate. When you want to find the graphs like up here and the line and the R value, you can solve them on the calculator. You can also solve them on Excel by making a scatter plot. But depending on the Excel edition you have, you may not be able to get the equation for the line and R. It's just easier on the calculator. Okay, so to find it, if we look at this example, the first thing you need to do is make sure your diagnostic is on. And to do that, we go second catalog. Catalog is where the 0 is down here. So second catalog. And then you got to go all the way to the D's. I don't know. Let's see if we could type it. Where's the D? Alpha, D. There we go. So then we want to go to diagnostic. Okay, well, it went too far. We want the one on. So notice it's at on. hit enter, enter again, and it says done. So I know that it's on. If you don't have it on, then it's only going to give you the equation for the line, and it won't give you the R. Now to get the equation line, first thing we need to do is enter our data. So you would go under edit. I always put my X value first and my Y value second. I just always do it that way. It can be done either way. It's just you have to be careful when you're graphing and things then that you have it right. So I always put X first. And I already typed in for this problem, a history teacher asked her students how many hours of sleep they had the night before a test. And then she kept track of the test. And here's the data. So if they slept, the one person slept 8 hours and got an 83. Another slept 7 hours and 86. Another slept 7 hours and got a 74. And so these are all the data. The top is the X because we want to see if our sleeps causes a test grade. Make sure that they go together. So 8 was 83. The next one, 7 was 86. We had 7 and 74. But you type them straight down. But they have to stay in order. And then second and quit. Now to make the graph, you go to stat plot. Because right now you're probably graphing just a straight line. To graph the scatter plot, notice this one looks like a scatter plot. You make sure that it says on. If it doesn't say on, you click on it and hit enter. And then notice I have the scatter plot. I put it on. Now if you want to go and graph lines later, make sure you got to turn it back off. But I turned it on. My X value was L1, my Y is L2, and then I hit enter. And then graph. And there's my graph. Looks like my data is increasing, which makes sense because the more sleep you have, the better you'll do on your test for a lot of different reasons. But studying is also part of it. So this would be the graph. Now a linear line will go right in between there. To find the equation for the line and the correlation, we go to stat, over to calc. Now notice there's two linear regressions. Not this one, this is different, it just doesn't have all the words. But there's number 8 and number 4. They are the same thing, except notice the slope is B on this one and the slope is A on this one. So either one, I always use mx plus b, so I use 4. So 4 and enter. Oh, you didn't have to enter. List 1 was x, list 2 was y. Our frequency was L2. And then you just calculate. So ax plus b. A is 6.2. B is 37.3, or however many decimal places the problem says. Now the correlation is R. You want to use R. It tells you more information. Okay, so right here, is where I put the equation. The A was 6.2x plus, because it's a positive 37. I only want one decimal place, 37.3. Now this line tells you the linear growth. The slope is the change in y and the change in x. So what this means in the example, you can read all of it, but I'll explain the example. As the hours increases by 1, you always use your x value by 1. The y value, in this case grades, increases by 6.2. So that's what the slope is telling you, the change in x and the change in y. X was the hour slept. So each additional hour of sleep, the grade increases by 6.2 points. The y-intercept is the 37.3. and it tells you when your X value is 0. So if a student had 0 hours of sleep, they'll probably receive about a 37.3 on the exam. Now this R value, the correlation, 0.86, it tells you how strong the relationship is. And this is close to 1, which means there's a strong relationship. It's positive, so it means it's a positive relationship. And R and A should both be the same sign, positive or negative. So there's a strong positive relationship. As the number of hours increase, you'll do better on the test. Another thing they ask for once you know your relationship with your equation, if students slept 8.5 hours, you could tell them approximately what they could get on an exam. And so if you have 6.2, you just plug from the equation we got earlier. Right here, this equation, in place of x, you'd put the 8.5. So if we want to find out in 8.5 hours, we plug it in here. 6.2 times 8.5 plus 37.3 is 90 on the exam. So if you get 8.5 hours on sleep, you'll probably get around a 90 on the exam. If you have any questions on that, let me know.